Okay, physical science students, we are nearing the end of COVID high school. I'm pretty excited about it. I've given the last lecture on notes for atomic structure, but I really want to hammer home different ways that we represent elements. They can be atoms, which is something that's neutral. They can be ions, they're going to have a charge. There are different isotopes, okay? Lots of different things. The first thing I want to do is I'm going to share my iPad with you. There are some terms that you've got to understand. I'm going to write each one of these down. I actually wrote them down last night, but on my whiteboard, iPad whiteboard, but it didn't save. So I'll just write it again. But dear. All right. It's cold in my house, and so I have on my lab coat. I thought maybe that would make you guys feel like we were at school because I'm wearing my tie-dye lab coat. All right. It takes me a while to get this done. There we go. Whiteboard. I'm going to create a new whiteboard. I'm going to write some terms on here, and I'm going to let me write them down first, and then I want you to come up with the definition for each one as best you can. If you know it off the top of your head, just write it down. If you don't know it, but you know you wrote it in your notes from one of my lectures, do that. Pause the video until you've answered all that you can, and then I'll give you the answers. Some very important terms that are easy to mix up because they contain different variations of 3 different words. So we have, I always do that, atomic number. And just to save space, I'm going to put a little hashtag. You guys call it a hashtag. It's used to be the pound sign, whatever. So we have atomic number. We have mass number. We have atomic mass. So those are really easy to mix up because they've got either atomic, mass, or number in them. But they're very important that you understand the difference. We also have little things called isotopes. You should know the definition of isotope. What are some other things I taught you? I believe I taught you a little thing called a cation. I'm trying to do all different colors, but I'm running out of colors here. An anion. And let's also understand the difference between just a plain old ion. So any of these that you know the definition to, pause the video, write down all the definitions that you know, and those that you don't know off the top of your head, use your notes, and then when you've answered all that you can, turn back on the video, we'll come with the answers. Atomic number. Atomic number is, I don't know if it's the most important, I guess it is. It's how the entire periodic table is arranged. It's what identifies the element. The atomic number, by definition, is the number of protons I have no idea where that came from. Let's erase that. Number of protons in an atom. Okay, it identifies who the element is. If I have 1 proton, I'm hydrogen. If I have 2 protons, I'm helium. If I have 3 protons, I'm lithium. If I have 4 protons, I'm beryllium. If I have 5, I'm boron. If I have 6, I'm carbon. If I have 7, I'm nitrogen. 8, I'm oxygen. 9, I'm fluorine. 10, I'm neon. 11, sodium. 12, magnesium. 13, aluminum. Okay? And the whole periodic table is arranged by atomic number. So get that down, get it in your head, get it in your brain, get it in your notes. Then we have mass number. Mass number, let's back up to atomic number just really shortly. Atomic number is found on the periodic table. It's the whole number on the periodic table. They are from 1 to, I think we're up to 24 now or whatever. 92, 1 through 92 are the only ones that are found naturally. All the rest have been synthesized or made in a lab. But every time we add a proton, we have a new element. Now, mass number by definition is the number of protons and neutrons in an isotope. The number of protons and neutrons together. You don't find that on the periodic table. What you see on the periodic table is atomic mass, that other number. All right, these are not the same thing. They're related, but they're not the same thing. You have to be told the mass number. The mass number needs to be told to you. You have to be told, I'm talking about carbon-14, the radioactive isotope, instead of carbon-12, the non-radioactive but more plentiful isotope. But just again, remember, by definition, mass number is the number of protons and neutrons, and it is not found on the periodic table. It's something that you're told. I'll be the one telling you, probably. If you have other people talking to you about mass number, you're cheating on me. All right, atomic mass, all right, related, but not the same thing. Atomic mass is the average mass numbers of all isotopes, of all naturally occurring isotopes, okay? And I showed you how to figure this out. What we do is we take the percentage that it's found in nature. Remember, I told you that it doesn't matter where we get a sample of an element from. I said I got one from Brazil and one from Russia. I could get them anywhere. I could get them anywhere in the universe. And they're going to have the same percentage of each isotope no matter where I get them from. That's just how those elements are found. So you take the percentages found in times its mass number, and then you add all those up, and that's how we got the little decimal number on the periodic table. Some of you guys are taking that decimal number and rounding it to the nearest whole number and treating it like it's the mass number. And you shouldn't do that. Okay. Now, let's go to isotope. Isotope, sometimes I use the word isotope, sometimes I use the word atom. Isotopes are just, let me get the right color here, we're in green. Isotope is atoms of the same element So that means they're going to have the same number of protons. If I'm talking about isotopes of carbon, it's all of the atoms that have 6 protons, but then some of them will have different numbers of neutrons. So atoms of the same element with differing numbers of neutrons makes them just a little bit different. They're still carbon. It's just carbon that acts a little different. I mean, if you were to know my siblings, you would know we're all pretty much the same element. We all just act a little different. I would probably be the radioactive one. So anyway, isotope, atoms of the same element with differing numbers of neutrons. And I've drawn pictures of those. And then we talked very specifically about one element that has 3 isotopes. And they're a special case because they're given names, like instead of just carbon 12, carbon being the element, 12 being the mass number, talking about that isotope, they have names. That's the ones that belong to hydrogen: protium, deuterium, and tritium. But when we look at a Bohr model of them, their nucleus is going to be the same as far as how many protons, but then they just have a slightly different number of neutrons. Let's move on to, I'm going to skip cation and anion, and we're going to go to just plain old ion first, because an atom that doesn't have a charge is an atom. An atom that does have a charge is called an ion. A charged atom. That just means that it doesn't have an equal number of protons and electrons. Remember, we care about protons and electrons because they're the two that have charges. Neutrons don't have anything to do with the charge of an atom. They just tweak its properties a little bit. Sorry that I keep coughing, but I think I might be dying. Anyway, so anything with a charge, any atom with a charge would be called an ion. Now, if it has a positive charge, if it has more protons than neutrons, more protons than electrons, it will be a cation. So we can just take, ion is kind of the umbrella for anything with a charge. And then of course we have to be specific and classify them. So a positive ion is a cation. That is going to be our metals on the periodic table. Anything that gives electrons away in order to become stable. Remember, we talked about that stable state is as simply as we can explain it. The stable state is an atom that has 8 electrons in its valence shell. And then if it has a negative charge, it's going to be an anion, a negative ion. So an ion is anything with a charge, and then specifically a cation has a positive charge and an anion has a negative charge. Now let's look at this picture. Let's see. Let's do that one. Let's do that one today would be great. Open up. I don't know why they're not opening. Nope. Well, this is annoying. All right, let's just go ahead and stop this video for right now because these won't open. And I will figure out what's going on, and then we'll do another video on how to read these things. These are Bohr models. We're going to read these. This is what a huge part of your test is going to be over. So you're going to want to stay tuned for the next video, which will be coming as soon as I figure out why these won't share. Well, now it's shared, so let's try it. I apologize. It just started working. Oh, heavens to Murgatroyds. Seriously. Okay, I'm getting there. Hold on a minute. All right, there's my beautiful drawing. I'm going to ask you a bunch of questions about these. Once I ask you the question, pause the video, try to answer them, come back, get the answers. Question number 1. Again, we call this a Bohr model. If ever you're asked, that's what they're called. If you don't know who Bohr is, You didn't listen to my lecture on the history of atomic structure.